In this video, we're going to look at how to make dilution calculations. Again, a really common thing that we do just about every lab. And so we often start off, right, with instructions to make a stock solution. So in this lab, we're just going to pretend we've already made this instruction set and make a stock solution 10 mg per mil of caffeine. You've done that. All right, so now you want to make final solutions. And in this case, each of those, the instructions say to make 10 mils. So we're going to use a 10 mil volumetric. And we want them to be 1 mg per mil, 0.3 mg per mil, and 0.02 mg per mil. So there's kind of two approaches to doing this. So the first strategy, especially if you take the first one, you say, oh, well, I have a 10 mg per mil stock, and I want to go to a 1 mg per mil final concentration. And so what I really need to do, right, is a 1 to 10 dilution. Okay, I can figure that one out. And if I do a 1 to 10 dilution, right, then what that means is I would take 1 mil of my stock, right, and then dilute it to 10 mils in my volumetric. So notice that means that if I were to actually do this without a volumetric, I would add 9 mils of water. I want to be that's clear. I'm not adding 10 mils of water. It's 1 in 10, which means there'd be 1 of the stock, 9 of water. Just so we have that clear. Okay, so that's how we would do it, you know, if we kind of knew, oh, 1 to 10. But if we look at a different one, like 0.3, now this strategy is kind of weird. I could go off of it, but it would be better if I had done this one, I think, a different way. So we're going to look at a second strategy to do this first one. So rather than just kind of figure out the dilution in my head, oh, that's a 1 to 10 dilution, instead, let's go with this. The first question is, what are the milligrams I need in the final solution? So let's start off there. Okay, so I might have my final solution is going to be 1 mg per mil, right? And I'm going to make 10 mils of it because that's what I said up here. I was making 10 mils, right? So if I do the math there, you can see that I end up needing 10 milligrams total. Okay, so I need 10 milligrams total. And then the question is, what's the volume of stock solution I need? So I'm just going to call this X milliliters, right? I need a volume of stock solution, right, that I need. And then I know, right, well, maybe I'll do it down here. 10 mgs times X mils of stock solution equals, let's do it this way. 10 mgs per mil. I like the whiteboard because I can erase. Let's do it this way. 10 mgs per mil, right? That's the concentration of stock times X mils is equal to 10 milligrams. That's what I want to find out. Well, obviously here, that's not a hard one, right? X is going to be equal to 1 milliliter. I've run out of space, so I'm going to go back up here. I'll keep my thing up there. Right, so that's not too bad. So I got the same answer, right, but it's easier to do it. But now if I look at, say, my 0.3 mg per mil one, it's a lot easier to do this one. So let's find the mgs first, right? So I find the mgs first. It's still 10 mLs of solution, right? So 0.3 mgs times 10 ml is going to mean that I need 3 milligrams, right? And so now I can do that same thing, 10 mgs per mil, that's the concentration of the stock, right, times X milliliters. I want to solve for the number of milliliters that I need to put in there, equals 3 milligrams. And so X here is going to be equal to 3/10, right, 0.3 milliliters. And so now you can see that that's a pretty fast and easy way to do it. Why did I put the low one on there? The low one on there, I wanted to make a point. So the 0.02, we've gotten into it. We know how to do this now. Times 10 ml, right? And that would equal 0.2 milligrams. And then again, 10 mgs per mil times x ml is equal to 0.2 milligrams. And so x is going to be equal to 0.02 milliliters. That's fine. In our lab, this is also equal just to not to 200, but to 20. I moved the decimal place 3 times, to 20 microliters. And we have pipettes in our lab that do 20 microliters easily. So sometimes people are like, I don't know how to if I can do that little amount. No, we don't use graduated cylinders and things like that, so we can. So 20 microliters would be fine. Anything down to 1 microliter, and you would be okay. Your stock solution would be okay. One thing to think about, a bonus question. How did we get that 10 mg per mg stock solution? I did a different video where I talked about how much to weigh out and using the molecular weight, but here you don't have to use the molecular weight. So if the first question said, make 50 mils of stock solution, and the question is, how much caffeine to weigh out, it's a pretty easy calculation, right? It's simply, all right, I want to make a 10 mg per mil solution, and I want to make 50 milliliters of it, right? 50 times 10 is 500, and I need to weigh out 500 milligrams of caffeine. So it's really simple to get to the amount we needed to weigh out to make that stock solution. Don't need any molecular weight if we're working in milligrams per milliliter.